Welcome to the third video of this kinematics series. We're going to look at some simple acceleration problems. A car is accelerating at 2.1 meters per second squared. How long will it take the car to accelerate from 90 kilometers an hour to 110 kilometers an hour? We're given the formula up the top here. Acceleration is equal to a change in velocity over time. The first thing that we want to do is list the information that we've been given. So we've been told that acceleration is equal to 2.1 meters per second squared. And we are given two velocity values. Our initial velocity is equal to 90 kilometers an hour, and our final velocity in this scenario is 110 kilometers an hour. Now, before we go ahead and start plugging these values into our formula, we actually want to make sure that we're working in the same units. So here, our acceleration is in meters per second squared, but the velocity values are in kilometers per hour. So we'll just find the difference here. Our change in velocity is going to be our final velocity minus our initial velocity, which is 20 kilometers an hour. And we'll convert that value into meters per second. So 20 kilometers per hour multiplied by the conversion factor for kilometers into meters. So we've got 1,000 meters in a kilometer. And also multiplied by our conversion factor, 1 hour divided by 3,600 seconds. So this kilometre and this kilometre cancels out, this hour and this hour cancels out, and we end up with 5.5 meters per second. That's the velocity value that we're going to use. That is the velocity value that we're going to use in our formula. So we're given our acceleration and we're given our velocity, and we're being asked to find time. So time is going to be equal to velocity divided by acceleration, which is 2.6 seconds. In part B, we are being asked to draw an acceleration time graph of this journey. Now this one's a pretty easy one. I'm just going to stick it here. Here we've got our acceleration and our time. Acceleration and time. We're given acceleration as being 2.1 meters per second squared, and the journey that we're referring to here is the acceleration from 90 to 110 kilometers an hour, which means that our acceleration is going to be constant. So if we mark 2.1 there, we can just draw a straight line like that. Hopefully your straight line's a bit neater than mine. Okay. And part C, there's a little bit more to part C. We're going to be drawing a velocity time graph. And in order to do so, we're going to do a couple more conversions. Our time is going to be in seconds, which means that we're also going to have to convert these two velocity values that we were given into meters per second as well. So we're going to do another conversion. So I'm just going to first of all mark my times. 1, 2, 3. This is in seconds. Okay, now I want to convert my two velocity values into meters per second, so I'm going to follow the same structure that I used down here. So 90 kilometers per hour multiplied by 1,000 meters over a kilometre, 1 hour over 3,600 seconds. These cancel out, and that's going to be equal to 25 meters per second. and 110 kilometers per hour multiplied by 1,000 meters divided by 3,600 seconds is going to give me 30.6 meters per second. And I'm going to use these values now on my y-axis. So let's go 10, 20, 30. It's a 20, not a 26. Okay, so my initial velocity is 25. My finishing velocity is 30.6, and that's at time 2.6, which is approximately there. So I'm very carefully going to put a dot there, and that's meant to be a straight line as well, but there we go. There is our velocity time graph there. And we can take it another step further, and we can use our velocity time graph to determine the distance travelled. So if I just do a tidy straight line there and another tidy straight line here, then I can geometrically calculate the distance travelled. So calculating the size of the rectangle, which is on the bottom, a rectangle, I'm going to multiply the length by the width. The length according to the time, the x-axis, is going to be 2.6 because it's 2.6 seconds, multiplied by the height on the velocity, the y-axis, which is going to be 25, which is going to give me a value of 65 meters, and then calculating the area of the triangle on top, which is going to be half base times height, the base being 2.6 again, and the height being 5.5, which I know from my calculation down here, the difference between my two velocities, which gives me 7.15 meters, and if I add the two of those together, then I get a total of 72.15 meters is the distance travelled. There we go.